ladies and gentlemen, let's take a look at our second lesson here in Chapter 7, Similar Polygons. So what we're going to do is identify similar polygons. So let's start talking about some of that vocabulary that goes along with it. So our vocabulary here is similar polygons are polygons that have corresponding angles that are congruent and corresponding sides that are proportional. And so what that means is, as we set up these ratios of sides, we're going to compare a side from triangle or polygon 1 to a side in polygon number 2, they're going to simplify down to the same fraction. So they're all of the sides, when you compare them, are going to simplify to the same ratio. Scale factor is the ratio of the lengths of similar polygons. So we talked about it's a scale factor of 3 to 5. If any of you have done model cars, we have 1 to 16 ratio. You'll see this 1 to 16 or 1 over 16. So that means your scale model is 1/16 the size of a original car. And so these scale factors they're just the ratio of the size. All right, so let's take a look at our first example. We want to use similarity statements. We're going to look at what it means to be similar. So it says triangle PRQ and triangle STU are similar. So they're telling us that right away. So what we want to do is list all pairs of congruent angles and then write the ratio of corresponding sides in statements of proportionality. So we're going to write proportions and then check that the ratios are all equal. So these similarity statements are written kind of the same way congruency statements were. The corresponding angles are going to be paired up, written in the same order in each triangle. So since angle P is the first named vertex in the first triangle, that means it's congruent to angle S. And because angle R, or vertex R, is written second, that means it's congruent to angle T. And then Q is congruent to angle U. So we're looking at how they're written in. So now what we need to do is set up sides in proportionality. So what they tell us here is that ST over PR. So if we kind of look at this, S to T, those were the first two vertices written together. So that's ST. Over here is going to be paired up with PR, the first two letters, so P and R. So if we write that ratio, ST was the smaller segment, so that's 8. And then PR was the larger segment of 10. And then that equals, we need to reduce that. Each of those can be divided by 2. So that is 4/5. So that's what we're looking for, the ratio of corresponding sides. We then can look and see, okay, the other ones would be TU over RQ. That's the ratio of the corresponding sides. If we take a look at TU, that goes to RQ. And then we would have SU going to PQ. All right, so now we look at those ratios. We already set up our first ratio for ST and PR. That went to 4/5. So now let's take a look at TU over RQ. TU is 16. RQ is 20. Both of those are divisible by 4 and go down to 4/5. So far we've got two sets of corresponding sides that have the same ratio. And so now we're going to look at US. US is 12. And QP is 15. Both of those can be divided by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And so we see that we do have the same ratio each and every time, that it simplifies down to 4/5. Alright, so let's take a look at determining whether the polygons are similar. If the polygons are similar, they're going to use the same logic that we just had. We're going to make sure that we have congruent corresponding angles. We're going to set up ratios of sides and make sure that those corresponding sides have the same proportion. So basically what we're doing now is doing the exact same work we did in example 1. We just don't know if we're going to end up with the same ratio in the end or not. So let's take a look. If I look at angle G, that's the first one they told me to take a look at. It's marked with 2 congruency marks. So I'm going to go and look at my second triangle, and the angle that's marked with 2 congruency marks is M. So that means angle G is congruent to angle M. Those are the ones that are matching up. If we look at angle H has 1 congruency mark. Angle K is the angle that has 1 congruency mark in the second triangle. So yes, we have a second pair of corresponding congruent angles. And then last but not least, J has 3 congruency marks, and so does angle L. So that means we have 3 pairs of congruent corresponding angles, which is what we need. So we're hitting that first mark. The corresponding angles are congruent. So we checked off the first part that we need to have. We now need the sides to be proportional. So if we look at MK, that's the first thing they tell us to look at, is MK. We would match that up with, if we take a look at that, M had 2 marks, K had 1 mark. I need to match that up with its corresponding parts, which is G and H. So MK had 12. And GH had 9. I need to simplify that. That's how I'm going to know if they're proportional. So divide each of those by 3. We get 4/3. They now take us, so we're kind of going around the horn, as I would call it. We're going to match KL up with HJ. So I have 16 over 12. Each of those can be divided by 4. Okay, we're looking for it to be able to divide them by the same factor and then end up with 4/3. And so now as we continue going around the horn, we've got LM, which is 20, needing to be put in a ratio with GJ, JG, which is 15. Each of those can be divided by 5, which is going to give me 4/3. And so we see all 3 times we set up a set of corresponding side ratios, we get the same proportion. So since all 3 ratios are equal, the corresponding side lengths are what we would call proportional. So we need congruent angles, proportional sides, so we know that the triangles are similar. All right. What I want you to notice here is what we're doing in our statement. We're still saying triangle GHJ, nothing different than we had. But look at our symbol here. We're using a little bit of a different symbol here. Our symbol for similarity is just a little wave. It reminds me of the tilde from my high school Spanish class. But instead of having the equal sign with the wave over it, we have just the wave to show similarity, because they're not the exact same size. One is definitely larger than the other, but they're larger by this consistent ratio. So we need to write our similarity statement. G was matched up with angle M because they both had 2 congruency marks. H was corresponding to K, and J was corresponding to L. So we're going to write our similarity statements the same way we did our congruency statements. And then what we're going to end up doing a little bit differently here is writing what that scale factor is. And that scale factor is 4/3. All right, so what you need to do is to decide if they are similar. And so you need to look and see. If we look here, we have X and D matching up. We have Y and E matching up. And we have Z and F marking up. So I see 3 pairs of congruent angles. So we have that. What you need to do now is go through and set up those scale factors and see if it's the same ratio. So I'm going to help you get those started. I'm going to kind of go around the horn there in alphabetical order. So we're going to have X, Y, and we're going to match that up with DE. We're then going to match up as we go around the horn, YZ. And we're going to match that up with EF. And then last but not least, we're going to have XZ be matched up with EF. So you need to look and see when you write these ratios of sides. So you are going to do now. Okay, and then we will check that in class during the warm-up time. All right, what we want to do now is use these similar polygons. They're going to tell me that two triangles are similar. RST is similar to triangle GHJ, but what I want to do is find the value of x. So because these triangles are similar, I know that the corresponding side lengths are proportional. So what I can do now is write a proportion. So they have me started. They said, let's match up GH, and we can match that up with RS. That needs to match up with something else, and we obviously need to include x. So we're going to take a look at these bottom two sides. Now we need to be smart and pay attention to how they wrote it. They wrote GH in the top. That means GJ has to be in the top of our second ratio. And then we're going to put RT in the denominator. What we're going to do is substitute in all the values that we know. GH had a value of 15. RS had a value of 10. GJ had a value of 9. And RT had a value of x. Now we've solved these proportions before. We did this yesterday in lesson 7.1. So now what I'm going to do is use the cross product property. 15x is equal to 90. I'm going to multiply each of those out. So I guess I should go back here actually and write this as 10 times 9. And so then we get 15x is equal to 90. Divide each side by 15. And so when we go through and divide by 15, 90 divided by 15 is 6. So x is equal to 6. What we're going to do is now look at what perimeters of similar polygons show us. We know that the pool and the patio around the pool are similar rectangles. Okay, they're the same shape, they're just different sizes. So what we want to do is find the ratio of the length of the patio to the length of the pool, and then we're going to find the ratio of the perimeter of the pool to the perimeter of the patio. So we're going to do length of patio to length of pool, perimeter of patio, perimeter of pool. We need to make sure we go in that order. So the length of the patio, if we take a look at that, the patio is obviously the outer edge of it. Our patio is inside of our pool, is 48 feet over 32 feet, the length of the pool. I could use the width because those dimensions are also similar. They just tell me to compare the ratio of the lengths. So when we take a look at that, 48 feet over 32 feet, each of those is divisible by 16. And we get 3 over 2. Now for some of you, that's not coming as quickly that you need to divide each of those by 16. So your calculator will simplify for you. That's why we highly recommend that you have a scientific calculator. And if you need help with that in class tomorrow, we can make sure we do a little review of that. Well, now I need to find the perimeter of the patio. Well, the perimeter, we worked on this a little bit yesterday, was 2 times the length of 48 plus 2 times the width of 24. Once again, this is something we can quickly punch in. This is going to be 96 plus 48, and that's going to be 144 feet. And now when I do the perimeter of the perimeter of the pool is going to be 2 times 32 plus 2 times 16. So this is going to be 64 plus 32, which is going to give me 96 feet. So you're going to have to do some calculations here, but now I want to look at these ratios. So the perimeter of the patio is this 144 feet. The perimeter of the pool is 96 feet. And even right now I'm sitting here going, okay, I probably should get my calculator out, what divides into both of those. But when I look at this, I'm realizing that 48 is going to divide into both of these. And if you can't see 48, then simply take 144 divided by 96 and turn that answer into a fraction. But we're going to get 3 over 2. So we have to get the same ratio for both perimeter and lengths. And that leads us up into our follow-up. What do you notice about those? So I want you guys just to give a nice written response. So write out. what I just said there. So those of you that take the time and actually listen to my videos, you'll know exactly what to write down. Check that. I'll check that in class tomorrow. All right. Now we're going to take a look at what we can learn from this. We have theorem 7.1, the perimeter of polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding lengths or sides. I like that a little bit better. The book uses lengths. I think side lengths is what we should look at. So what that means is that in the triangle, if we add up all the sides, DE plus EF plus FD, and compare that to AB plus BC plus CA, that's going to be equal to DE being put in a ratio with AB. It's going to be equal to EF being put in a ratio with BC. And it's going to be equal to a proportion with FD being put in a ratio with CA. So FD over CA. Alright, so what we're going to do now is take a look at our checkpoints. We want to find the value of x. Now remember, ladies and gentlemen, we can find x by setting ratios of sides. So some of you, this is going to be just a quick mental math problem. You look at this, you see what's going on here. But what I can do now are set up ratios of corresponding sides. QR corresponds to TU. So I can set up QR with TU. And I can set that equal to PR with SU. So I can set that equal to PR over SU. So if we do that, we should have 16 over 8 is equal to x over 9. So now what you need to do is finish this problem. It then says find the ratio of the perimeter of STU to the perimeter of triangle PQR. Now it's going to be difficult to do that without knowing the perimeter of STU. So this will be our warm-up. And this we will do in class. Okay, but you should have number 2 finished so that we can go on with that. And we'll see all of you in class tomorrow. Enjoy your algebra review here.